All right, for our lesson today, we are doing lesson 7 of module 4. Today, by the end of the lesson, you're going to be able to simplify some equations and figure out if the answer has a unique solution, no solution, or infinitely many solutions. You'll know you're successful when you can simplify or solve an equation and determine if it has one solution, no solution, or infinite solutions, okay? First thing we're going to do is review what we've learned so far. Then we're going to do some examples. You'll have a few exercises. We'll close out the lesson and you'll do your exit ticket on your own. All right, for this side, we're just going to review some of the skills and strategies we've learned throughout the last couple of weeks when we solve equations. The first one I want to go over with you is to always draw a line through your sign, okay? It's the first thing you want to do each time you get an equation before you solve. It'll help you stay balanced. It'll help you stay organized. That brings us to our second skill review, okay? Always stay organized and neat. Make sure that you're not, being super messy, because then you can't even read your own work and you might mess up things. You might forget steps. Make sure that anything you do to the left side, you do to the right side as well. Third thing I want to review with you is to always follow the order of operations, okay? And those include parentheses first, exponent second, multiplication and division third, whichever one comes first, and then addition and subtraction last. Fourth thing to always keep in mind is to distribute. Anytime you see a number on the outside of parentheses that has terms inside, expand that, okay? Multiply that 5, like I'm showing you right now, to both terms inside to expand your question, your expression, so that you can then, move things around. Next, always remember to combine your like terms, right? You're starting with probably a pretty long expression or equation. You want to make sure you take everything you can and simplify it. So anything that you can combine. Which brings me to my next skill review, and that is to always do keep, change, opposite, okay? Turn your subtraction signs into addition signs so that you then can move things around and combine like terms. And number 6 kind of goes hand in hand with number 7, which is keep, change, flip. So anytime you are dividing a fraction, you turn that division into multiplication by doing keep, change, flip. And then the last thing I wanted to review with you today is to just always try to eliminate your fractions, whether you want to turn them into decimals, or you can just multiply the entire equation by the denominator, and then they'll be eliminated, okay? But life is a lot easier without fractions. So this is our skill review. Take notes on this on your note page before we move forward into our examples. All right, for our examples today, we are going to complete 3 questions that all look pretty similar, but you'll see very quickly that our answers are different. Now, when we do these, I'm going to be explaining to you what our answers mean, okay? So some of these will be familiar, some of these will be new to you, okay? I'm going to do number 1 first. As always, I start by drawing a line through my sign. On the left side, I see a minus sign, so I'm just going to do keep, change, opposite, so I have a plus sign, and I can rearrange this however I want. I'm going to move my x's on the left side, so I'm going to move 5x from over here, take it away, put it on this side. Over here, I'm left with 2 x's plus negative 3 equals 5. From there, I'm going to move my number, my negative 3, to the other side, so I'm going to do plus 3. This cancels, I'm left with 2x equals 8. And then my last step here, to get x by itself, I divide by my coefficient of 2. And I get x equals 4. So this is what we've been doing since, honestly, you probably started some of this kind of work in 6th grade. This question shows us that we have an answer, and the only answer that's ever going to work for this is x equals 4. So this is a one solution answer, or sometimes we call this a unique solution. Because nothing else is going to work unless x equals 4, okay? All right, we're now going to do number 2. You'll notice that the numbers are pretty similar. I start by drawing a line through my sign. And just like before, I see a minus sign on the left side, so I'm going to change that to plus negative. Did my keep change opposite. And from there, I'm just going to start. Now, I can either move my x's to one side first, or I can move my numbers to the other side first. I'm going to start with just doing my numbers. So I'm going to add 3, and I'm going to add 3. Over here, I get 7x equals 7x plus 8. Now, just looking at this, that doesn't make any sense. 7x's can't be the same thing as 7x's plus an additional 8, okay? But we're just going to keep solving. So I'm going to move these 7x's to the other side, and you'll see what happens. Cancels, cancels. I'm left with nothing over here. And on this side, I'm left with 8. And we talked about this in our last lesson. This does not make sense. 0 will never equal 8. This does not work. That's not equal. So this is a no solution. And we know this because 0 does not equal 8. Okay? All right, today here's your new learning. So you're going to learn a different classification for an equation. Again, similar numbers. I'm going to draw a line through my sign, and I'm going to start to solve. One thing you might notice is that we have the same terms on both sides. On the left side, I have 7x. On the right side, I have a 7x. On the left side, I have a minus 3 or negative 3. On the right side, I have a negative 3. Okay? So you will notice something very soon about this problem that gives way to our answer. Okay, but I'm just going to go ahead and solve like regular because it's not always going to look this simple. So first thing I'm going to do is change my minus sign to a plus sign, and then I'm going to work. Let's say I just move my 3's to the same side first, or my constants. On this side it cancels, I'm just left with 7x. On this side it also cancels and I'm left with 7x. Alright, now from here I can keep working, or I can look at that and that can be my answer. But I'm going to keep working here. So to get x by itself, which is always my objective, I'm just going to divide both sides by 7. And because I'm dividing by the same number that's already on both sides, they both cancel out, and I'm left with x equals x. Okay? Now, when you ever get an answer that looks like this, x equals x, 4 equals 4, 3 equals 3, 21 equals 21, that means that there are multiple answers that will work for this. Okay? That means we could plug in any number here, and it could work. Okay? We say that this is called infinite solutions. And again, that's whenever it says blank equals itself. X equals x. 1 equals 1. Okay? So these are the 3 different types of classifications for linear equations. You can either have a linear equation that has one solution or a unique solution. It can have no solution, which means your answer just does not make sense. Or it can have infinite solutions, which means you can plug in pretty much anything for that number and it will work. Okay, there's multiple solutions for that. All right, for the exercises practice, you have these exercises posted in your class Kik. I'm going to go through each of them right now and go over them. But before I go over them, please pause this video and go attempt them on your own, okay? You're going to do, I think, 4 exercises on your own, okay? And I want you to solve them, solve these equations, and tell me if it has one solution, no solution, or infinitely many solutions, okay? So pause this video right now. Before I go over these, try your exercises on your own. All right, now that you've done your own exercises, I'm gonna go ahead and start solving them. Here is the first one. My first step is to always draw a line through my sign. And now I'm gonna start solving. So I don't have any parentheses, I don't have any exponents. I don't see any multiplication or division, so I just have addition and subtraction. So at this point, I'm going to use keep change opposite, change my subtraction to addition, and then I'm going to start combining my like terms, okay? I'm going to use red to solve this so you see my work. So I see a minus sign, I'm going to do keep change opposite, and it looks like that was my only minus sign. So on the left side, I have 2 terms I can combine, 11x's and negative 2x's. So 11 take away 2, 11, 10, 9. I have 9 x's left over here. And I have a plus 15 left over here. On the right side, I have 2 numbers that I can combine, 8 and 7. 8 plus itself is 16, so 8 plus 1 less than itself is going to be 15. Okay. From here, I already can kind of tell what the answer to this question is going to be, okay? Right now it says 9x plus 15 equals 9x equals 15 plus 9x. So I'm just going to move one of these over to one side. I'm going to take away 15, take away 15. Cancels, cancels. I get 9x equals 9x. And just for the sake of time, I'm going to stop right there. Is 9x always going to equal 9x? Yes. So this problem has infinite solutions. Okay, I could have kept solving and I could have got x equals x, or you could have done it a different way and got 15 equals 15. But no matter what, your answer for number 1 is infinite solutions. All right, moving on to exercise number 2. First step is to draw a line through my sign. And then I'm going to start. Do I have any parentheses? Yes, I do. I can't combine anything within those parentheses, but I know that those parentheses represent multiplication, so I'm going to first distribute. Okay, so 3 times x is 3x. 3 times 14, I'm going to do it off to the side because I don't know it by heart. 42. And you'll notice they had a minus sign in between, so I keep that minus sign. And then I just have my plus 1. Oops, I put 3. Equals negative 4x plus 5. All right, from there, do I have any parentheses? No. Any exponents? Nope. Multiplication? Nope. Division? No. And then all I have left is addition and subtraction, so I'm going to change my subtraction signs to be all addition, so I can move things around, and there was just one of them. So now I'm going to combine like terms. On the left side, I have a negative 42 plus 1, so this becomes negative 41. Keep everything else. On the right side, I can't combine anything. Okay? From there, I'm going to move my variables to one side, my numbers to the other side. I'm going to add 4 x's just so I can get rid of that negative sign. You do it to one side, you do it to the other. 3x plus 4x, 7x, plus negative 41 equals 5. Okay, from there I'm going to move my number to the other side. Plus 41, plus 41. This cancels. I'm left with 7x equals, let me move down a little bit, equals, sorry, that was a 41, 46. Okay, and then from there I'm going to divide by 7. This cancels. I'm left with x equals, and I could do this in my calculator and get a decimal. I could leave it as an improper fraction, but that wouldn't be simplified. Or I could write it as a mixed number. I think the easiest thing for me to do here is just going to be to divide 46 divided by 7. And I get 6.571. I'm going to just round it off there. Okay? What do I know about this answer? Will this be classified as one solution, no solution, or infinite solutions? This is going to be one solution. And again, we also sometimes call that unique solutions. All right, moving on to exercise number 3. First step is to draw a line through my sign. That line was really weird. All right. And I'm just going to go ahead and get started. I have some parentheses. I can't combine what's in the parentheses because they're not like terms, but I can use the distributive property on my parentheses. Okay, negative 2 times 5x's is negative 10x's. And negative 2 times 10 is negative 20. I keep my plus sign in between because that's what they had up top. Okay, and that's all I've done in this first step. All right, from there I'm just going to start over. Any parentheses? Nope. Any exponents? No. Multiplication or division? No. I only have addition and subtraction left, so I'm going to go ahead and remove my subtraction signs. So there's just one. This becomes plus negative 7x. Okay. From there I'm going to combine like terms. On this side I have negative 3x's and negative 7x's. I can combine those. This becomes negative 10x's. And then on the right side, I cannot combine these things. They're not like terms. All right. From there, I am going to move some things around. So it's up to you whether you want to move your variables first or your numbers first. I'm going to go ahead and just move my numbers or my variables first. So I'm going to do plus 10x on the left, plus 10x on the right. And you'll see that these both cancel out. And I'm just left with 32 equals negative 20. Now this is as small as I can get it, so this is my answer. And what does this tell me about the solutions to this equation? Well, this tells me that there is no solution because 32 is never going to equal negative 20. Okay? All right, moving on to the last exercise I'm going to do here. I'm going to draw a line through my sign and get started. Do I have parentheses? Yes. I can't combine what's in the parentheses, but there is a coefficient on the outside, so I'm going to use that to multiply. I'll actually use red to multiply onto the inside terms. 1/2 times 8 is the same as saying, what's half of 8? Half of 8, I know that by heart, that's 4. So this becomes 4x's. And then again, half of 26. 1/2 times 26, that's 13. You can do that in your calculator if you need to check. Okay? Keep the plus sign that they had. From there, everything on the other side stays the same. And I start back over. From here, I'm going to move my variables to one side, my numbers to the other side. It does not matter what you do first. First thing I'm going to do is just move my 4x's. And you'll see really quickly that I'm done. I get 13 equals 13. Is 13 always going to equal 13? Yes. So what does that tell me about my equation? How many solutions? Infinite. Okay. And we are done with our exercises. All right, just to close out and review what we've done this lesson before you do your exit ticket, I'm going to go over the 3 different types of solutions we have and what they look like. So the first one is one we've been pretty familiar with. It's one solution. We also call this a unique solution. And what this looks like when you solve is you'll get to the end of your problem and it'll say something like x equals negative 4. Okay? If you get that your variable equals a number, then that is a one solution. Okay? All right, moving on. We also have no solution. So you guys learned this over the last couple of days, what it means when an equation has no solution. Basically, it means it doesn't make sense. It can never happen. It's impossible. And that would be if it said something like yikes. Say 5 equals 7. Will 5 ever equal 7? No, it's never going to work. That's never going to be true, so there's not going to be a solution. Okay? The last one that you learned today is infinitely many solutions. I think I spelled that wrong. I'm just going to put infinite. And infinite solutions means you get to the end of your equation, you've simplified as much as possible, and you get something that says x equals x. Or it could say something like 5 equals 5. Or negative 2 equals negative 2. Now in each of these cases, that's always going to be true. Nothing's ever going to change. A number is always going to equal itself, so this means infinite solutions. Okay? So that was our lesson today. You are now going to move on to your exit ticket and complete it independently. All right, you guys, last thing you're going to do for this lesson is your exit ticket. It is posted in your class Kik for you to solve these questions. You have 3 different equations. I want you to solve them and then tell me if they have one solution, no solution, or infinitely many solutions. Okay? And you are done for this lesson.